Good afternoon and welcome to the webinar simulation tool PTV Vissim within the MORE project. I'm Peter Sukenik, Technical Product Manager at PTV headquarters in Karlsruhe, Germany, and I'll be the presenter today. For those of you who are not familiar with the MORE project, let me introduce it with just one slide. So Project MORE is about multimodal optimization of road space in Europe. It is a European Horizon 2020 project. It's led by University College London. And there are 18 partners cooperating within this project, including 5 cities. And MORE delivers tools assisting cities in their road space design process. And if you like to have more info about the MORE project, please visit the website of the project. The major involvement of PTV within this project is the further development of the simulation tool PTV Vissim that will mimic the user behavior in streets and on roads, including the delivery of performance indicators. That was very briefly about the project itself, and now I would like to present quickly what's new within Vissim, because we released the newest version 2021 few weeks ago. And let me start with the features related to the vehicle simulation. At first, allow me a little explanation. In Vissim, we distinguish between parking spaces, parking lots, and parking lot groups. In the old parking lot dialog, you can find the attribute group. In Vissim 21, we rename it into destination group because it better describes the meaning. It is used for dynamic assignment. But we also have a new attribute called evaluation group that is used for the parking evaluations. You can find it in the list and in the dialog as well. The new parking evaluations are available for parking spaces, parking lots, parking lot groups, and for parking routing decisions. You can activate them on the tab Result Attributes. Besides that, new parking states are available for vehicles. These indicate whether the vehicle is parked, waiting for parking, driving to the parking space, driving back on the original route, or is blocked. So what you get from these new evaluations, many attributes like number of vehicles entering, leaving, parked, occupancy duration, parking fee, and all is for spaces and lots and lot groups. Similarly, there are new attributes for parking routing decisions, like number of parking requests and number of parking requests accepted, declined, parking duration, and so on. So where to use all these evaluations? Anywhere where the curbside activities or parking itself are the subject of interest, like busy local streets, drop-off and pickup points, airports, parking facilities, and so on. And as always, besides the numerical values in result list, you can use color schemes to illustrate the situation or to demonstrate the results. Like here on the picture on the right, you can see the occupancy rate for each parking lot at a parking facility. Here you can see the visualization of the newly implemented parking states for vehicles. Some of them are driving to the parking spaces, heading back to the static route, or are blocked while leaving the parking space. So you get a clear overview of what's going on in the model. Now let me switch into Vissim to show you a few of the possibilities. So let me start a simulation in this simple example where you can see vehicles entering the network and parking and different parking lots. Now I will switch to another layout which will show us the parking states for vehicles. So now the color of vehicle indicates the parking states, and here in the legend you can see which parking state the vehicle has at the moment. How to activate this? Easily when you go to the network object window on the left side and click here and go to the drawing mode, you need to select color by parking state, and then you can activate the legend here with this button, and that's it. Let me switch the layout for network editor to another one, and let me show you occupation rate for species. And let me switch off the vehicles so we can see the values only. And now you can see the occupancy rate in person for each parking space in your model, and also how the value is changing during the simulation. What you can see here depends what you choose for color scheme configuration for parking lots. So as a drawing mode, you need to select use color scheme, and then you need to pick up the attribute you are interested in. In my case here, it's the occupancy rate for current simulation run and current time interval for all vehicle types. Let me switch now to parking lots. And I will switch off the vehicles again so we see the evaluation values only. And you can see that for those parking lots, I get only one value, not for each parking space, but a value for the whole parking lot. Let me switch to evaluation groups, and I will stop the simulation so we can see it clearly. When I double click on a parking lot in the dialog I showed in the presentation, you could see that there is the new attribute evaluation group, and you can also select several evaluation groups for one parking lot. Here in my case, these three parking lots on the main road, they belong to evaluation group number 2, and all these small parking lots here belongs to evaluation group number 1. So I will start the simulation again, and I will switch to another evaluation type, which is entering vehicles, which will show us the number of entering vehicles for each parking space. Again, I switch off the vehicles, and I will use the quick mode to come a little bit further in the simulation. And here in the configuration, under evaluation configuration, then you can check what kind of evaluations are activated. And I use the evaluation for parking lot groups, parking lots, parking routing decisions, and parking space. And I have a few predefined layouts for showing different kind of evaluations. Okay, I go back to my presentation. The next one is custom lane change behavior. So if needed, you can define smooth lane change if a driving behavior has a user-defined attribute called smooth lane change and contains the number of a free distribution. This distribution is used as the cause of the change of the lateral position of the front edge when changing lanes. On the picture, you can see the default lane change maneuver in Vissim, that's the orange line, and a defined smooth lane change, that's the blue line. And optionally, you can set the lane change duration as well. If the driving behavior additionally contains a value in the numeric user-defined attribute lane change duration, this value is used as duration of the curved lane change. Otherwise, the fixed value 3.6 seconds. And please note that the normal lane changes in Vissim still take 3 seconds. So what you see is a comparison between the Vissim default lane change, white dots, and the smooth lane change, red dots. Within the more project, this will be probably not important feature, but you can imagine that you have another use case where you want to see realistic lane change maneuver, and you want to use your own data collected in the real world and to let your vehicles behave according to those empirical data. Routes, attributes, and formula of formula routes. It is now possible to access attributes of a route in a formula route. Before, only attributes of pedestrian or vehicles were available. And this allows to define formulas without table lookups, where previously they had to be used. This does not only make formulas look tighter, but also allow to do without constants. And this makes formulas more proof against modeling mistakes, since formulas more often can be copied without modification for all formula routes, and this also means that they can be reused in different projects more frequently. There are new result attributes, demand latent and delay latent, for vehicle inputs and parking lots. Latent means that it is demand or delay collected by vehicles that could not enter the network. And these result lists contain same information as network evaluation, but separate per vehicle input and parking lot. So if in your use case you have a overloaded model and not all vehicles can enter the network within the simulation time you set, then you will find a non-zero values for latent demand and latent delay. And these values are useful to find out how many vehicles couldn't make it and how much time or how much delay they collected before they were even able to enter the network. Visualization is the impressive part of a micro simulation, and we have some great new features for you. You already know from the previous version that you can show 3D buildings for the whole area in your projects, but what about if a building is hiding something more important on the ground or will be demolished? In such case, you can switch the visibility of individual buildings on or off. So from the context menu of Network Editor in 3D, you can choose Edit Building Visibility and then pick up the individual buildings to be changed in visibility. And with the corresponding modifier, you can do aerial selection or toggle selection. And worth to mention, static 3D models switch overlapping 3D buildings off automatically. This might be the star solution. So later, additional option maybe edit like user-defined colors or transparency of for individual buildings. So we expect feedback from you to know what's useful or important to add. And let me show you this feature directly in Vissim. So I have a very simple model here. In my case, actually, I have only one object in my model, and it's this section here. And when I switch to 3D and I activated here show buildings, then I can see the 3D buildings everywhere where the tiles overlap with the objects I have in my model. So this is what I can see. And from the context menu here in the network editor in the 3D mode, I can choose edit building visibility. And then I can pick up an individual buildings, also several of them. And when I confirm, then these buildings disappear. I'll do it again. And when I want to see the building again, I can just switch here to visible and confirm, and the building will be visible again. Let me show you a little bit more. Sometimes you have several blocks, and if you don't want to select all of them, there is a solution. When you press Alt on your keyboard and then confirm with your mouse click, the whole block will be selected, that the whole group of blocks will be selected, not just one piece. So that is an easy way how to switch off or on all of them. Okay, you can do also an aerial selection when you move your cursor through the network. Then you can select several buildings at once and you can switch them off or on. Let me do it again because I want to switch them off. But now there is the green color indicating that I can switch them on. Let me show you one more thing which might be interesting. If you have static 3D objects in your network and when you move them somewhere where the 3D buildings are located, in such case the 3D building will disappear automatically, so you don't need to switch the building off. So that's it, how to switch off or switch on the buildings. AV recording is possible in a 2D mode now, so you can show labels and bars. It works as for 3D recording, so you define keyframes, positions, and movements, and network layouts. In the previous version, only AV recording in the 3D mode was possible. How to keep the software powerful but easy to use with the handling improvements. Simple ITS tools. An easy way to simulate intelligent transport system without the need for VSAP or programming. These are available in Vissim already, but now we have some additional buttons in the vertical toolbar and layouts for comfortable configuration. The definition of the major flow is now combined with the two-phase actuated signal controller. The pedestrian crossing signal controller has been accessible through the context menu, now also with its button and a preview of the new objects to be placed. Rival crossing signal control with the automatic placement of the call and checkout detector. And ramp metering controller, this is brand new in Vissim and it is based on the linear algorithm. And the layout offers parameters to set. For the new tools from the vertical toolbar, I presented a new short help is available. It appears in the right upper corner of the network editor and it tells you if you will use the tools. It tells you what kind of tool you have in use, what to do now. Gives you info about the modifiers, what is the next action, and how many actions to follow. And if you will use the tools time to time, it will guide you easily through the whole process. If you are an experienced user and do not need it, you can just switch the short help off. Let me go to Vissim again and show you few features, new features. This is my simple model where I have a main road which is crossed with a pedestrian crossing here and later with another minor roads. And in this case, I'm using here link, which is used as pedestrian area. It's prepared for pedestrian crossing. And I have two areas here for pedestrians, and our pedestrians will move from one area towards another one and will cross this main road here. And to add very easily and very fast a pedestrian crossing, signalized pedestrian crossing, then we can go to this vertical toolbar and choose create pedestrian crossing. And you can see here the short help appears in the right upper corner and tells you select pedestrian link. And when I move my cursor towards the pedestrian link and I hover over the link, then you can see a preview of the new objects to be placed there. So when I confirm by clicking on my mouse, all the objects are placed here. So the conflict areas are here already, the signal heads are here, and the detectors are here as well. And the signal controller has been created. So when I start the simulation now, let me switch to 3D mode. So in a few seconds, we will see vehicles and also pedestrians crossing the main road. And only if pedestrian comes to the signal head and will be detected by the detector there, in that case, the pedestrians will get a green signal. It's now, and afterwards the vehicles will get a green signal again. So it's like a pedestrian crossing in reality with the push button. When the pedestrian comes, I can press the button and wait until the green signal. So just a few clicks and all necessary objects and logic is generated. Similarly, here we will use this button for defining the major float, but we want to create both. So not only setting the major flow, but we also want to create two-stage controller. Because we have this major road and we want to put a signalization here on this intersection, and the vehicles on the minor road should get green signal like only on demand when there is some vehicle, because the demand there is very low. So the first I need to do, I can read it here in the short help, I need to define the start section for the major flow. So I define the start section, I move my mouse and define end section, and I need to confirm that these conflict areas within this circle belong to that intersection by clicking. And I also could change the default parameters here, but if I'm satisfied with these values, you also can see the preview of all objects to be placed, and if everything is fine, then you can just confirm here, and the objects are added, placed into your network, the new signal controller is created, and everything should work. So let me start a simulation and switch to the 3D mode and have a look what happens on this intersection. So when a vehicle comes on the minor road, will be detected and will get the green signal, and afterwards on the main route the vehicles will get the green signal back and will remain this green signal until there is another request from the minor road. So it's very simple, two-stage detector activated. Okay, let's move in our network to the right, and let's say we want to create a railway crossing, and for that we have a button here, so I use it, and the short help tells me define start of the railway crossing. So this will be the start, this will be the end, and you can see the preview of all objects to replace. So the signal heads, this will be the checkout detector, and somewhere here on this link a little bit further away, this is the calling detector. It looks fine to me and I'm satisfied with the default value here, so I confirm that. And then I can start the simulation, and I will switch to 3D mode, and you can see a train or a tram approaching, getting the green signal, crossing the intersection, and afterwards the vehicles get back the green signal. That's because the tram is detected on the calling detector, which is placed by default 200 meters from the signal head, like somewhere here in this position. And then the tram will get the green signal, and when the tram crosses the checkout detector, then the vehicles can get back the green signal. So it's very easy way how to create such railway crossing where the train gets the green signal on demand. In some cases, the position of this detector maybe will not fit, then you can just grab it with your mouse and move it to the right position. So the train doesn't need to stop at the intersection, but fluently comes through the intersection. Okay, let me open the list of signal controllers, and you can see these are my 3 new signal controllers I created using these new tools on the vertical toolbar. And I still can, by double clicking on the signal controller, open the dialog for the signal controller, and I can go to the tab signal groups, and I can change the default settings here, like a minimum green times or minimum red, or the clearing times, or any other available attribute. So also afterwards, after the creation, you still have access to those parameters, and you can change them if needed. The last thing I want to mention on the which is placed on the vertical toolbar, and it's new, is ramp metering facility, the creation of it. And in this case, the short help says select on-ramp. So this will be my on-ramp, and I need to pick up the place where the signal height should be placed with the detector. And then as the second step, I should select the freeway. So here, somewhere on the freeway, the detectors should be placed. I need to select the right position. And later on in the layout, I can decide if also the queuing detector should be created or not, and I can change the default attributes here. If you would like to know more about what is the appropriate value for these parameters, then I recommend you to look for linear algorithms or for papers with linear algorithms, description of the linear procedure for ramp metering. And you can find a lot of materials describing the experiences and the appropriate values. And when you do so, you can see here we have a new signal control for the ramp metering. And when you start a simulation, and you have also volumes placed there, then it starts and it's functioning from the beginning. So this is how it works very easily, very quickly for such simple configuration like pedestrian crossing or two-stage controllers. If you would have 3, 4, or several stages, then in that case you need to use another approach, not this simple ITS. But if you are satisfied with two-stage controller, then it's easy to use it. I go back to the presentation. As next, we have attribute modifications. This is very powerful feature. Attribute modification sets a specific attribute of some or all objects of a specific type to a value calculated by a formula. And important thing, it is possible to access the old values and perform cumulative calculation. Because of attribute modifications, we changed the menu entry scripts into actions. And under actions, you will find the scripts as before, but also the new attribute modifications, and this opens the list of attribute modifications. So when you add new attribute modification, you will need to choose object type and target attribute. You need to define the active time from simulation second to simulation second, and how often the modification should happen in simulation time steps in each simulation time step, or every second, or every 10th, or whatever you need. And obviously, in many cases, you can choose modifications instead of scripts to do the work. But script would be still needed for special actions like object adding or removal. Let me show you a simple example in Vissim how you can work or how you can use the attribute modification. So let me explain this simple model. I will start a simulation here. Vehicles are entering the network and driving towards this parking facility here. They park there for a certain time, and afterwards they leave the parking lot and will continue back on the static route. So I have here in my model, this is my static route used by all vehicles, and I have here placed the parking routing decisions with routes leading to individual parking lots here in this parking facility. And you can see here that I activated the parking state, the visualization of the parking state. So the color of vehicle indicates the parking state, and when the vehicle is leaving the parking lot and is on the way back to the route, it's indicating by this yellow color. And let's say that because of some reason in your project, it's important to know how long does it take to get from the parking lot back to the original route, so back to this crossing sections. And you would like to know these times. And there is no direct attribute for that, but you can use the attribute modifications to calculate that time. And for that, I prepared a user-defined attribute for vehicles. I called that attribute time back. And we will need to add an attribute modification. So I will click on the plus button here, which opens the dialog for attribute modifications. And you can see I have two major fields here, object filter and the field for the formula. But at first, we should here select the object type. And this will be vehicles in the network. And the target attribute will be the user-defined attribute I prepared, the time back, and I want to store or calculate the time and write it into this attribute. So I want to put here the value which is there, or I want to take this value which is stored there, and I want to increase the values. So I write here plus 0.1, and that's because I kept the period here 1. So this attribute modification will happen in each time step, and my simulation resolution is 10, which means 10 steps in 1 second. So within one time step means 0.1 second. So I will increase this value with 0.1 in each time step. But I don't want to do this for all vehicles, but only for those vehicles which are on the route back to the original route. So I need to set a filter, and I will use the parking state, the attribute parking state for that. So I will filter only vehicles with a specific parking state, which is called back to route, but I need to write a number here. And I need to write a number which belongs to that specific parking state. And I don't know exactly which number belongs to which parking state. So I will just keep here 1 for the moment. And what I need to do is that I need to go to the COM help, and I will look for parking state. And there is parking state enumeration, or if you go to vehicle attributes, you can find here parking state. When you click on parking state, you will come to description of that attribute. And here, when you click on the value type, you will come to this table. And I need to look here in this table for parking state back to route. That's what I'm interested in my use case, and it tells me it's 6. Okay, that's the value I was looking for. So I go back to my attribute modification to my filter, and instead of 1, I will write 6 here, and I press OK. And now I will start the simulation again. And here for vehicles coming in the network, you can see the value which is stored in time back. It's empty now because there is no vehicle on the route back yet, but there will be in a few seconds. This one started already, and you can see that the value here is accumulating. Yeah, it's increasing because that vehicle is on the way back. And when this vehicle will cross this section here, so let me now simulate step by step until the vehicle reaches this position, which is now. And you can see also the parking status change is none. And this value will not change anymore because this is the time this vehicle needed to get from the parking lot back to the original route. And when I continue simulating, then you will see here also for the other vehicles, these values are calculated, but only for those vehicles which are on the way back on the original route. So this is how it works. Very simple example, and at the end of my presentation, I will show you also few other examples for attribute modifications because they are really powerful. Attribute selection and the improvements we implemented. This one is used very often when you are using our software. And it's even better now because there's a new field for fast access to 5 previously selected attributes. And you can find here the attributes which have been selected most recently within the last hour. There is search filter on the top, which considers also the sub-attributes now, as well as relations, and the character slash separates the corresponding levels. And you can find there also links to the upper levels in the hierarchy. User-defined color schemes can now be named and added to the list of predefined color schemes in the color scheme dialog. They can also be selected, renamed, or written and deleted there. Named color schemes are saved into the layout file and can be additionally read from any layout file to extend the current list of color schemes. And small tip for you, if you want to create a nice color ramp, you can use the tool mentioned here on the slide. I think the best would be if I show you how it works directly in Vissim. Just let me load another example. Yeah, here you can see a few pedestrian areas, and for those the use of color scheme was chosen here for drawing mode, and density was chosen as an attribute. So I wanted to keep the color scheme. I just wanted to click here to see the color scheme. Here on this button, you can choose a predefined color scheme, or you can add a new one by clicking on this button. You can name it as you wish. My color scheme, and I will confirm. And then you can perform any changes here. And when you are satisfied with the thresholds and with the colors, then you can save this into your newly defined color scheme. So I will just choose the button here, override with the shown color scheme. So I press OK. And let's say that you want to create your own color ramp, and I mentioned, let me go back to my presentation. That's here, and this is the link to the tool which might be useful for you for creation of ramps. So a few seconds. The internet seems to not working. Okay, let me try another one, another browser. Oh, here it works. So this is a simple example of a ramp color here, and there is the syntax you can modify. And let's say you want to have this first color and the last color, and 8 in between. So I press the create ramp, and I got 10 of them. I can copy, and I will go to Excel. I will paste it here. And in this column, these are the hex codes for my colors. And the last thing I need to do is replace this hashtag with, let's say, FF. FF stands for the value 255 or 255. And then I have the codes in a format which Vissim accepts. So I will copy these values, and I go back to my Vissim model, and let me delete one so I have only 10, and I just paste the values I copied in Excel. I paste them here, and I got this nice ramp here, color ramp. So that is the way how you can easily create any color ramp of your choice and paste it here. So you don't need to fill out all these values for each number or pick up it from the ramp. Okay, so that's it, how it works with the colors and named color schemes in Vissim. The next we have here named layouts. The graphic user interface for layouts change in Vissim. This applies for the network, editor, list, charts, and camera positions as well. Drop-down list is replaced by a button, and view icons allow comfortable changes like renaming or deleting. There is a new attribute, recording scope, available for storyboards and animation recordings. So you can define in which simulation run the files are to be recorded. So you can choose between every run or first one only or the final run only. There are many smaller things to mention as well. If you are going to import from OpenDrive format, you might profit from following improvements. Import of the file format later than 1.4 is possible. The lane width variations are transferred into Vissim by short links and connectors with a linear width change. Set coordinates can be imported now, and you can import an OpenDrive file by using a new COM method if you are using the COM interface. There are A&M improvements. So export and import of the abstract network model got the speed per transport system now. This brings additional speed information for links, inputs, public transport lines. It is not implemented for the parking lots yet. Sometimes you want to share your model with someone else, so you need to know which files are needed to run the model. And with the model archive, you can save the network file, the emtx file, and the referenced files into one archive, which is a zip file. The option is available under File Export Model Archive and allows convenient sharing of model packages, uses predefined subfolder structure, so not a user-defined one, and scenario management is not supported. Please note that an external signal controller might not include all referenced files, and the external signal controller must be installed on the target machine as well. Driving simulator interface is used when you connect Vissim with an external simulator. And now you can add and remove vehicle during the car simulation. And the simulator can take control over normal Vissim vehicles during the simulation or pass it back to Vissim. So you could have your own simulator, your own steering wheel and pedals, and you could control one specific vehicle, and you could drive through the Vissim network and interact with Vissim vehicles using this driving simulator interface. That is possible, and you can pass the control of your vehicle to Vissim or take control back from Vissim to you. Good news is that Vissim is faster now because we implement a new model memory allocator, which comes with 5 to 15% speed gain for bigger networks, and a speed up to 25% is possible. A few words regarding the evaluations within the more projects. So a few specific things I want to mention. I have a few points here on my slide. The first one, for example, number of stops for vehicles. You can find out through not just one evaluation, but sometimes you can use different evaluations with different settings. So for example, for a number of stops for vehicles, you can use the node evaluation, but also queue counters. And you might set different conditions for these two types of evaluation. So please keep this in mind when evaluating. Then, for example, then the next point here, a number of stops for pedestrians. That's a little bit tricky because the pedestrians in the network, when they come to the stop because they reach some waiting area, their speed doesn't drop to zero. Their speed is oscillating with non-zero values, and actually it's the same in the reality. If you would have a look on the midpoint of the human body, then this midpoint is moving a little bit, oscillating, even if our foots are frozen at some position. So if a pedestrian comes to a pedestrian crossing and stays there and waits there, still the midpoint of the body is moving, and how fast and with which amplitude. That's based on age, for example, and also could be influenced by illness and so on. But you could use attribute modifications to recognize when a pedestrian stops in the model. The next point here is walking and sitting pedestrians with 3D model switching, and that's something I would like to show you in Vissim directly. Just let me load the right model. So this is a simple model where pedestrians are coming to a bank, and some of them are sitting here. And you can see that when a pedestrian comes to this bank, then the 3D model of the pedestrian will change into a sitting pedestrian. And then later on, the pedestrian will stand up and move again. So let me slow down the simulation speed so you can see it. So the workaround for this example is that you can switch the 3D model or the pedestrian type for each individual pedestrian. And with the pedestrian type, you will switch also the 3D model of the pedestrians. And in the past, when I created this simple example, I created it with a script, with a simple script looking like this. And this script is just checking if an attribute which is called sitting, which is a user-defined attribute, equals to 1. So it gets the collection of all sitting pedestrians. And if this is true, then it sets a new pedestrian type. And with the new pedestrian type, also the 3D model of the pedestrians is changing. So let me show you this in 2D view, how it's done. So there are routes leading from the original area to these small waiting areas here, and on each these small waiting areas on the bank, there is pedestrian attribute decision, and when a pedestrian reaches this area, then the value is switched to 1. And then the script can recognize that and can change the pedestrian type, and with the pedestrian type, the 3D model will change. But now with attribute modifications, it's possible to do it without using the scripts. So this is the same model, but there is no script. There are just attribute modifications inside, and it is doing the same job. So it is switching the pedestrian type, so it looks like there are sitting pedestrians, and afterwards it switches the pedestrians type back to the original one, and it looks like a moving pedestrian. So I have 4 attribute modifications here, which are doing the job. The first one just saves the origin pedestrian type into a user-defined attribute called origin type. This one will change the pedestrian type only for filtered pedestrians. So for those who are sitting and for those who do not have the pedestrian types which is predefined for the sitting pedestrians. So if there are such people there on the bank which are sitting but still have a pedestrian type of a walking pedestrian, in that case change the target attribute pedestrian type to this value. So it is with one if condition, because if it's man, then change to a sitting man, otherwise change to the sitting woman. So that's how it works. And then again, this will change the pedestrian type back to the original type when the pedestrian is still sitting, but it's the last time for the pedestrian there, last time steps, but the area is not his destination area anymore, because the pedestrian will leave the bank, and in such case we can switch back to the original type. So this is how you can do that. And okay, so I spoke for 1 hour, so I think I could have a look on your questions if there are any. So let me have a look if there are any questions. So, and if you didn't write any question but you would like to ask something, so please use the feature and go to webinar where you can write a question, and I can read it then and answer it. So I can see here one question. I'm a new participant here. Can I get the tutorials for beginner on how to use PTV Vissim software? So if you are a beginner, there are several ways how to learn Vissim. The first one is you can attend the training. So you can go to the PTV website and look for trainings, and you can attend a training. They are online now, so you don't need to travel to Karlsruhe or to the place where the training should be realized. Then under help there is com help, and when you open it, then you can find I don't mean the com help, didn't want the com help, but PTV Vissim help, and you can look for the topics you are interested here in the com help, or you can open the PTV Vissim manual under help and PTV Vissim manual, and there are also, you can look for PTV Vissim webinars, and you will land on the page for webinars. I will switch to English. There is a resource library, and you can choose the products you are interested in. It's Vissim in this case, and you can find a lot of webinars here with different topics. So you can watch a webinar which will explain the basics to you, or also some special topics. And you can also go to YouTube and you can look for Vissim tutorial, and you will find a lot of tutorials. Some of them are prepared by PTV directly, some others are created by other users, and you can find a lot of topics from beginners to advanced topics. So that is the source you can use. And there is also PTV Vissim forum on LinkedIn. You can join this group, and you will find here posts in PTV Vissim forum. So our users can ask questions here, and other users can reply. Sometimes people from PTV reply. You can find a lot of information here as well. And yeah, what to mention? Maybe one more information about the training examples. Within each Vissim installation, usually under this link here, uses public documents, then PTV Vision, then the Vissim version, then you can find examples training. We are in 21 now, examples training with a lot of training examples for different topics. And you can open them in Vissim and have a look. For each example, there is a PDF with a description of the examples, which explains what is the example about and what kind of modeling technique is used there. And that is very, very useful. What I would recommend you for the more project is one specific example under public transport and waiting long here for one station. Let me open it. So I start the simulation here in this example, and you will see buses approaching from the left in the network. So public transport vehicles will enter the network. Let me speed up a little bit. So bus is approaching. At first, the bus will stop here in this area, and the people will alight from the bus, but then the bus will continue to one of these gates. And the pedestrians waiting here in this waiting area, they get this information that there is the bus of a specific line coming, and in that case they will start to move towards that gate, and afterwards they will board the bus. And this process of getting the information when to go and to which gate, this is done by the use of attribute modifications. So you can use this solution, this approach here, and apply it in your use case. Okay, I don't see any additional questions here in the question window in GoToWebinar. So that would be all from my side. And if you are involved somehow in the MORE project, if you will do some modeling work for the cities participating within the MORE project, and you have further questions regarding the modeling technique or regarding the evaluation, so please do not hesitate to contact us, and we can provide you support for the MORE project. And again, if you are interested in some additional information regarding the MORE project itself, please have a look on the web page I mentioned. It's roadspace.eu. That's all from my side. Thank you for your attention and have a good day. I see there is a new question. Are the training available on the site are free? No, the trainings are paid by the webinars. They are free, so you can have a look on the webinars. They are free of charge, but if you want to attend a training which takes a day or 2 days, those are paid, and the information about the price you can find on the website, on the PTV website. Will send us a link of the recording to this webinar. Yes, we can do that. I think that we can put the link to this webinar on the web page of the MORE project, and yeah, we will do that. We'll let you know. The next question is there any PDH certificates for this webinar? No, for this webinar we don't issue any certificate, but if you attend a training, then you will get a certificate. So you are welcome, and see you next time.